G'day learners, in this video we're going to be looking at factorizing expressions. So hopefully you understand as our learning goal here the meaning of the terms HCF and factorize. And your goal is, and this is the key part here, that you can factorize an expression by using the HCF, and you're basically applying the distributive law in reverse, and that is basically what factorizing means. And we've done the previous video on what the distributive law looks like, and we're basically applying this in reverse. So again, the key things that you do need to remember before we continue is what HCF means and also how to apply the distributive law. So if you need to go back and watch some previous videos, please do that. So that will give you a good idea of what we are covering here. So what we need to do firstly is practice finding the HCF, because that is pivotal in how we do our factorizing expressions. So again, the highest common factor of a set of numbers is the largest factor that divides into each term. So we've got three examples here. So the highest common factor of 15x and 21y, and I can tell is 3. Okay, so I know that 3 and 15 and 21 is the highest possible common factor between those two numbers. Now for HCF of 10a and 20c, I know that the highest common factor will obviously be 10. And this one here was a good example that we might be able to use. The highest common factor between 12x and 18xy is 6x. Now I can see that I've got an x in there because the x applies to both terms. So it's 6x as well. So when we're going to use finding the HCF, what you want to do is these two steps. You want to use your divisibility rules to try and determine what the HCF is, and then you want to look for a common pronumeral, and that's what's going to be your HCF, which you'll factorize with, which we're going to be looking at very soon. So just a couple of examples here. Let's find the HCF for the following terms. Okay, and we have 20 and 35. I know they both end in a 0 and a 5, so it's obviously going to be the highest common factor here is 5 for these two numbers. Next, we want to look at 18a and 24ab. Okay, so I've got 18, which I know is going to be a multiple of 6, and 24 is also going to be a multiple of 6, so it's going to be 6. But I also can notice here that they both have a in it, so it's going to be 6a. That's going to be the HCF for both of those, because both can be divided by 6 and also a. As you see, it's got a common a there. Now the other example here, we've got 12x and 15x squared. I know that the highest common factor between these two, they can both be divided by 3 as their highest common. So it's going to be 3, but I also can see that there's an x here and there's x squared here. So what we're going to use is 1x. They both have 1x in common. So here, x here, and there'll be one of the x's here. So this one here is 3x. Now the reason we do this, the reason we find the HCF, because that helps us factorize an expression. This is the key part of the lesson that I want you to make sure you go through. So first you take the HCF, so the ones we've just done before, and you put the HCF of the terms on the outside of the brackets, and then you divide each term by it, and you leave those results on the inside of the brackets. So last lesson we looked at the distributive law of how to expand brackets. Now we're going to be doing the reverse, where we're actually breaking it down and placing it into brackets, and this is why we need to find the HCF. So the example is here. So we have 10x and 15y, and the highest common factor is 5. So as it says, we first take the HCF of the terms outside the brackets. Okay, so I'll put the 5 on the outside of the brackets, and then I divide both of these by 5, and that goes on the inside of the brackets. So in this case, I have 5 on the outside. 5 divided by 10x will be 2x, plus 5 divided by 15y will be 3y. So again, all we're doing here is a reverse of expanding brackets. So the three steps are: find the HCF, place the HCF on the outside of the brackets, and then divide each term by the HCF and place that on the inside of the brackets. So let's do some actual examples now. And we've got 6x plus 15. Okay, so their highest common factor here will be 3. They can both be divided by 3. So the 3 goes on the outside of the brackets. And then I'm going to divide both terms by that number. So 3 divided by 6x will be 2x. Okay. Then plus, continue adding the plus in, and then how many times does 3 go into 15? It will be 5. And you can always check your answer by going in reverse. by effectively expanding the brackets. So I know that 3 times 2x equals 6x, and I know that 3 times 5 equals 15. So you can always check your result as you go through. So now let's look at an example that may involve a pronumeral. And the first thing again is we always want to do is find the HCF. So I have a 12a and an 18ab. So already I know that there's a common pronumeral which I will circle, which is going to be used in a HCF. And now I want to find the number. So the common factor between 12 and 18 will be 6. Okay, so I can write 6a on the outside of the brackets. And then I'm going to add everything now on the inside of the brackets which I have divided. Okay, so how many times does 6 go into 12a? Now, because I am adding an a, I don't need the a on the inside with 12a. So 6 times 6 goes into 6a goes into 12a just twice. Okay, and then I have, sorry, fix that. Then I have how many times does 6a go into 18ab? So I will cross out the a because I'm going to be adding that with the HCF. So it will go 3b. And again, I can check that and confirm that by 6a times 2 will be 12a, and 6a times 3b will be 18ab. So let's look at this example here. We're using a minus symbol now. Okay, and we want to find the highest common factor. They don't have a common pronumeral, but I can work out that they have a common factor of 7. So I can put 7 as my HCF. And in there, in the brackets, 7 times what equals 21x, I can say that that will be 3x minus 7 times what equals 14y, and I know that will be 2y, close of brackets. So it is really quite simple once you get the hang of it, but again, it's just working in reverse order of the distributive law of expanding our brackets. We're just bringing it down. So again, the key reminders are that you find the HCF, place the HCF on the outside of the brackets, and then divide each term inside the brackets by the HCF. So write down any questions or struggles you may have that we can address in class, and we'll be able to move on from there. Thanks, guys.